Hello everyone. So today we are going to solve a very important question generally known as to sort a k-sorted array or nearly sorted array. So first of all I will explain you what the question says and then we will proceed with the coding solution. Let me take an example. Like we have an array 6, 5, 3, 2, 8, 10 and 9. And we have to sort it in ascending order. Okay, if this was a normal sorting question, we could have easily used merge sort or quick sort, having time complexity O n log n time. But here the twist comes when we get a k. What this k says basically, here at every kth element, means every element is at the k position away from its correct spot. Means like if I sort this, if I get the what should be the result, basically the result should be 2, 3, 5, 6, 8, 9 and 10. If I sort it, I should get this result. And if I see 2 here, 2 should be placed there. Here if I sort it, 2 should be here only. And how much, means like how much away 2 is from its correct position? Of course 3 position, 1, 2 and 3, and k is given in the question 3. Then we can practically see, yes, like how 2 should be placed and how much away it is from its correct position. Okay, so for every element it is valid. Every element is k position away from its correct position where it should be in the sorted array. Okay, so how we will proceed? We are going to use heap here and min heap here to get an optimal solution. Why we are going to use min heap is basically, in the min heap the topmost element is the smallest one, and as we go down we get the largest element, and we want to get a sorted array in an ascending order. That's why we are going to proceed with the min heap instead of max heap or something else. Okay, I will show you diagrammatically first, and after that we will move to coding solution. So I will make a heap here. I should make it here only so that you can see the array. Okay, so first of all I will push k plus 1 elements from the array to the heap. K plus 1 means if k is 3, I have to push these 4 elements into the heap first in a single round. Okay, why we are moving with the k plus 1 and not k is basically, you can clearly see whatever I have to keep here, whatever I have to place here at the 0th position, I am going to get that number in the k plus 1 only. K plus. Now we will push it one by one. First 6, then 5, then 3 and then 2. And as we pushed k plus 1 element, then we are going to pop the topmost element, and here we can clearly see the topmost element is 2, and suppose our resultant vector name is result, so we are going to push the topmost element into this array. Okay, so 2 is placed here. Now we are left with 6, 5, 3. Now again we will move to next. Now we are going to get 8. 8 will be placed here only because it's a min heap. And now as we pushed k plus 1 element, again the heap will say take out the topmost one. Okay, so we will take out the topmost one, which is 3, and 3 should be placed here only. Then we will move to next, which is 10. 10 should be placed here. And now the topmost, this is pushed away. Now we are left with 5, 6, 8, 10. Now topmost is 5. 5 is pushed away into the result. And after that we are going to push 9. 9 is going to be pushed in somewhere here in between 8 and 10. So okay, we are going to do it 5, 6, 8, 9 and 10. So now the topmost element, okay, 5 is not there, 5 is already pushed. So now the topmost element is 6. We are going to keep 6 here. Left with 3 elements in heap, 8, 9 and 10. And for this left out elements we are going to run a while loop which will say pop the elements until the heap is not empty, and by this we are going, after that loop we are going to get a final array. This is our final array. I hope you understood what I want to say and how we will proceed. Now we will move to coding solution, and we will see how we will write that code and how we will run our all the test cases. This is the question, nearly sorted array, and I have already written the code. Okay, so first of all, I took a priority queue, and here I wrote greater int. This greater int tell us that this mini is a min heap basically, because we are using a min heap. So this greater int factor tells the compiler too that we are using min heap. After that, we are using a resultant vector to store the result, and then there is two for loops to push the k plus one element into the heap, and then to pop the topmost element and push it into the result, and then move to next element. Okay, so this for loop is basically doing that, these two for loops. After that, we have a while loop. As we have already seen that after doing all these operations, we are left with some elements, like we are left with k elements. So for those elements to be pushed into the resultant vector, we use a while loop which runs till the mini is not empty, and it pushes all the left out element into the resultant vector. And at the end, we are going to just copy the resultant vector into the array. Since it's a void function given by GFG, so we cannot return anything. So here we just copy the resultant vector into the array. I hope so you all understood what the question is and how it should be solved. Let me compile and run this. Okay, so it passed. After submitting, okay, so it's done. Thank you so much. I hope so you all understood what I told you, what I told. Let's meet in the next session. Thank you.